November 8, 1942. Near Algiers, Algeria. The captured American vehicle sat at the edge of a hastily abandoned British supply column, its engine still ticking as it cooled in the North African sun. The crew had fled when Stuka dive bombers announced the arrival of Wehrmacht reconnaissance elements sweeping eastward from the German strongpoint at Tunis. Standard procedure dictated that abandoned enemy vehicles be destroyed or bypassed entirely. But the unit commander, an Oberleutnant from the 23rd Panzer Division, had different orders this morning. "Get our mechanics. I want a full inspection of this American machine before we torch it." What the Afrika Korps mechanics discovered over the next hour would fundamentally challenge everything they believed about German engineering superiority and American industrial capability. The revelation would not arrive as a sudden shock, but rather as a slow, creeping understanding that built with each test, each measurement, each comparison to the vehicles they had maintained for years in the unforgiving desert. The small identification plate riveted to the dashboard read Willys MB, contract number W-860123, serial number 174928. The Americans called it a Jeep. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The first mechanic, an Oberfeldwebel named Klaus Richter, who had spent 14 years servicing German military vehicles before the war, approached the vehicle with professional skepticism. American equipment had earned a mixed reputation among Wehrmacht soldiers. Some items proved surprisingly robust, others failed catastrophically under field conditions. The question was always which category a new piece of equipment would fall into. He opened the hood, expecting to find the sort of complicated, over-engineered power plant that characterized most military vehicles. What he discovered instead made him pause and reconsider his assumptions about American design philosophy. The engine compartment was immaculate in its organization. Every component was accessible without special tools. Color-coded wires ran in clear, logical paths. Each part carried a stampede identification number. The mounting brackets used standard bolts that could be removed with ordinary wrenches. No specialized equipment required. No factory-trained technicians needed. No mysterious adjustments that only experts could perform. In nearly 15 years of maintaining Kubelwagens, Opel trucks, and various other Wehrmacht vehicles, Richter had never encountered such deliberate, thoughtful engineering specifically designed for ease of field maintenance. The revelation was profound, almost disturbing in its implications. The Americans had designed this vehicle, expecting ordinary soldiers with minimal training to maintain it under combat conditions, far from workshops and supply depots. The Go Devil engine displaced 134 cubic inches and produced 60 horsepower at 4,000 revolutions per minute. By German standards, these numbers were unimpressive. The Kubelwagen's engine, though smaller, was more sophisticated in design. But as Richter examined the Jeep's power plant more closely, he began to recognize that the Americans had pursued an entirely different engineering philosophy, one that prioritized practical reliability over theoretical performance specifications. This engine was not built to be perfect according to engineering textbooks. It was built to be simple, reliable, and above all, producible in massive quantities by workers with average skills using standard machine tools. A farmer with basic mechanical aptitude could service this engine using nothing more than the tools that came with the vehicle. No precision instruments required. No complex adjustment procedures. No need to consult factory manuals for routine maintenance tasks. The Americans had apparently accepted that conscript soldiers and hastily trained mechanics would need to keep these vehicles running under the worst possible conditions, thousands of kilometers from proper facilities. By November 1942, the disparity between American and German vehicle production philosophies had become impossible for informed observers to ignore. America would eventually produce over 640,000 Jeeps during the war. Germany would manage approximately 50,000 Kubelwagens. More troubling than the raw numbers was what this production disparity represented about fundamental differences in industrial capability and design thinking. The Jeep embodied American mass manufacturing principles perfected over decades of civilian automobile production. Standardized components, simplified assemblies, design features specifically chosen to enable production by semi-skilled workers using 5 interchangeably parts. The Kubelwagen, by contrast, reflected German preference for precision engineering, none of which translated well to wartime mass production under increasingly difficult circumstances. The Afrika Korps Oberleutnant, approached as mechanics, continued their detailed technical inspection. His expression was serious, focused. Should we destroy it now or take it with us? The senior mechanic, Richter, looked up from the engine compartment, carefully choosing his words. He understood that his assessment would be written into reports that travelled up the chain of command to headquarters staff, who made decisions about German vehicle development and procurement. Sir, this vehicle is remarkable in ways that matter for combat operations. It has been designed by engineers who understand field conditions and the limitations of average soldiers under stress. The officer frowned slightly. German. Engineering is the finest in the world. Everyone knows this. Our vehicles represent the pinnacle of automotive development. Richter did not argue directly. Instead, he simply gestured toward the Jeep's four-wheel drive system, pointing at the transfer case mounted between the transmission and the rear axle. Sir, please observe this mechanism. A single lever engages four-wheel drive. One lever, one simple motion. Any soldier can master it in seconds. Our Kubelwagens require multiple operations to shift between gears, and most lack four-wheel drive entirely. In soft sand, that difference determines whether a vehicle completes its mission or becomes stuck and abandoned. The Wehrmacht's primary reconnaissance vehicle, the Volkswagen Type 82 Kubelwagen, was indeed an excellent machine in numerous respects. Ferdinand Porsche had designed it with characteristic German attention to engineering elegance. The vehicle was lighter than the Jeep by approximately 700 pounds. It consumed less fuel per kilometre travelled. Its air-cooled engine eliminated the vulnerability of liquid cooling systems to bullet damage and freezing temperatures. These were genuine advantages that German engineers had carefully calculated and deliberately designed into the vehicle. But the Kubelwagen possessed one critical, crippling weakness for desert warfare and any operation across difficult terrain. It was rear-wheel drive only. In the soft sand of North Africa, the mountainous terrain of Italy, the endless mud of the Russian front, that limitation proved devastating in practice. Regardless of how elegant it appeared on engineering drawings, the Jeep, by stark contrast, could power all four wheels whenever conditions required it. The system was so straightforward that an illiterate soldier could master its operation in minutes after a brief demonstration. No complicated procedures, no special knowledge. Just pull one lever and four wheels received power simultaneously. The mechanics continued their systematic examination of the captured vehicle. The suspension system employed simple leaf springs, a solution that German engineers would have considered crude and unsophisticated compared to the Kubelwagen's advanced torsion bar setup. But leaf springs offered one overwhelming advantage. They could be repaired or replaced in the field by any mechanic with basic metalworking skills and access to flat steel stock. Torsion bars, when they failed, required factory replacement and specialized tools for proper installation and adjustment. The electrical system followed the same design philosophy. Basic components, robust construction, clear labeling. Minimal complexity. The fuel delivery system could operate on almost any grade of gasoline without modification or adjustment. a capability that proved invaluable in combat zones, where fuel quality varied wildly from depot to depot. Most troubling of all was what Richter's measuring tape revealed about the vehicle's weight distribution and construction margins. The Jeep weighed approximately 2,450 pounds fully equipped. The Kübelwagen weighed 1,540 pounds. The difference was 910 pounds of what German engineers would automatically classify as excess weight, unnecessary mass that reduced performance and increased fuel consumption without apparent benefit. But the Afrika Korps mechanics, seasoned by months of brutal desert operations, where vehicles either survived abuse or died, recognized the method behind what might appear to be madness to theoretical engineers working in comfortable German facilities. That extra weight translated directly into durability and operational reliability. The Jeep's frame was deliberately overbuilt, designed to handle punishment that would destroy lighter vehicles optimized for efficiency rather than survival. The Americans had decided that reliability under abuse mattered infinitely more than optimal fuel efficiency calculated under ideal conditions. They had built a vehicle expecting it to be misused, overloaded, driven recklessly by inexperienced soldiers, and subjected to conditions that no reasonable engineer would approve of in peacetime. And they had engineered every component to survive that abuse anyway, operating under the assumption that vehicles in combat would face the worst possible treatment. This was not the American incompetence that Goebbels' propaganda films had promised German soldiers. This was engineering philosophy focused relentlessly on practical reality rather than theoretical perfection. This was design thinking that prioritized what actually worked in the field over what looked impressive in specifications and technical manuals. The reconnaissance unit brought the captured Jeep back to their forward maintenance area, a collection of camouflage nets strung between destroyed buildings on the outskirts of a small village. Over the next 4 days, mechanics conducted exhaustive field trials designed to stress every system. They drove it through soft sand, where Kübelwagens struggled and frequently became immobilized. They loaded it well beyond its rated cargo capacity. They subjected it to abuse that would have crippled most German vehicles after a few hours. The Jeep absorbed everything without complaint. Its engine temperature remained stable even under heavy load in intense desert heat. Its transmission shifted smoothly despite inexperienced drivers grinding gears during tests. Its suspension flexed over obstacles that would have bottomed out lighter vehicles. Most impressively, in soft terrain, where rear-wheel drive vehicles required careful throttle management and often needed help from recovery crews, the Jeep simply powered through, its 4 driven wheels clawing for traction and almost always finding enough purchase to keep moving forward. The low-range gearing, selectable through a second lever on the transfer case, allowed the vehicle to crawl over obstacles at walking speed with tremendous torque available at the wheels. The Kübelwagen's gearing, despite its reduction hubs, could not match this capability. German vehicles could navigate obstacles with skill and careful driving. The Jeep could brute force its way through terrain that would stop German vehicles entirely. Word spread rapidly through Afrika Korps units operating in the region. The Americans had deployed a vehicle that outperformed the Wehrmacht's reconnaissance vehicle in almost every metric that mattered for actual combat operations. Fuel efficiency? The Kübelwagen was superior. Comfort? Debatably, depending on personnel preference. But ability to complete missions across difficult terrain? Carrying capacity? Ease of maintenance? Reliability under stress? The Jeep held clear, undeniably advantages. Officers and mechanics from neighboring units requested permission to examine the captured vehicle. The reactions followed a predictably pattern that Richter observed with growing concern. Initial skepticism based on propaganda claims about American industrial weakness, followed by grudging respect as they examined the vehicle's construction. Then, dismay as the full implications became clear to anyone with engineering knowledge and combat experience. One visiting supply officer, Hauptmann Werner Vogel, had worked in German automotive plants before being commissioned and sent to North Africa. He spent an entire afternoon studying the captured Jeep, taking notes, asking detailed questions, measuring components. His final assessment, delivered to the assembled officers and senior NCOs from multiple units, was blunt and devastating in its implications for Germany's industrial war effort. Gentlemen, this represents a fundamental difference in manufacturing philosophy between American and German approaches to military vehicle production. We Germans build vehicles to achieve engineering perfection according to classical principles taught in technical universities. The Americans build them to be manufactured quickly, in massive quantities, by workers with average skills. In total war, where industrial output determines which side can sustain combat operations, that difference matters more than any individual vehicle's technical specifications. He walked around the Jeep, pointing out specific features as he explained the broader implications to officers who were beginning to understand that their assumptions about German industrial superiority might be dangerously wrong. Observe this engine block. It is cast, not precision machined to fine tolerances the way we would insist upon in Germany. The Americans deliberately sacrifice a small amount of theoretical performance to achieve massive gains in production speed and manufacturing simplicity. They can train a semi-skilled worker, perhaps a housewife who previously assembled refrigerators, to build one of these engines in a fraction of the time required to build a comparably German engine to our exacting specifications. Now multiply that time saving across every single component in this vehicle. He pointed to the stamped metal body panels, deliberately crude in their finish compared to the carefully formed panels on German vehicles. These panels are primitive compared to our metalworking standards, but they can be produced by the thousands in factories that previously manufactured household appliances. The Americans have mobilized their entire industrial economy for war production. Every refrigerator factory, every washing machine plant, every commercial vehicle manufacturer has been converted to produce military equipment using slightly modified versions of their existing machinery and workers. We cannot match this production capacity. Our industrial base, though sophisticated and capable of producing superb individual examples, was never designed for the sort of total mobilization that American industry has achieved. Our skilled craftsmen are being conscripted into military service, leaving factories understaffed. Our machine tools are wearing out without replacements. Our supply chains are disrupted by Allied bombing. Meanwhile, American factories operate safely behind oceans, staffed by motivated workers earning good wages, supplied with unlimited raw materials, protected by distance from any possible attack. The assembled officers stood silent. Vogel had articulated what many had begun to suspect through months of combat against increasingly well-equipped Allied forces. Germany's traditional philosophy, which emphasized quality and precision, made perfect sense in peacetime competition. But in total war, where victory went to the side that could sustain combat operations through sheer material abundance, the American approach of producing adequate equipment quickly was proving devastatingly effective. That evening, Richter spent hours composing a detailed technical report documenting every aspect of the Jeep's design that he had examined. He noted strengths and weaknesses with scientific objectivity, but the overall assessment was unmistakably to anyone reading between the carefully neutral language. The Americans had achieved something that German engineers, despite their theoretical superiority, had failed to accomplish. They had created a vehicle optimized for the realities of modern mechanized warfare rather than the ideals of engineering textbooks. The report made its way up the chain of command, one of thousands of similar documents flooding into Wehrmacht headquarters from every front where German forces encountered American equipment. Technical intelligence officers compiled these field assessments into comprehensive analyses that painted an increasingly troubling picture. The Americans were not merely matching German production, they were outproducing Germany by ratios that seemed physically impossible given what German intelligence had estimated about American industrial capacity before the war. In late 1942, Wehrmacht intelligence commissioned a comprehensive study of Allied vehicle production capabilities, hoping to quantify the threat and identify potential vulnerabilities. The results, delivered in early 1943, confirmed their worst suspicions and exceeded their most pessimistic projections. American factories were producing military vehicles at rates exceeding 1,000 units per day across all types. Ford's Willow Run plant alone was completing a B-24 Liberator heavy bomber every 63 minutes at peak production efficiency. American shipyards were launching Liberty cargo ships faster than German U-boats could sink them, fundamentally undermining the naval blockade strategy that was supposed to strangle Allied logistics. The raw statistics revealed a truth that some German planners had tried to ignore or dismiss as impossible. Exceeded the combined total output of Germany, Italy, and Japan together. And American production was still ramping up, with new factories coming online monthly and existing facilities continuously improving their efficiency. The captured Jeep became something approaching a celebrity within its unit. Soldiers competed for opportunities to drive it, finding it more reliable and capable than their assigned German vehicles. Officers began using it preferentially for forward reconnaissance missions, trusting its mechanical reliability more than their own equipment. When parts inevitably wore out from hard use, replacement components were scavenged from other captured Jeeps with surprising ease. Everything was genuinely interchangeable in ways that German vehicles, despite official specifications claiming standardization, never quite achieved. By early 1943, Afrika Korps units had captured dozens of Jeeps as the North African campaign intensified and American forces poured into the theater following Operation Torch. Wehrmacht mechanics formed informal networks across different units, sharing maintenance knowledge and trading scarce spare parts. A black market emerged for captured American vehicles and equipment, with working Jeeps commanding prices far exceeding their theoretical value because everyone who had used one recognized its practical superiority for desert operations. Then came May 13th, 1943, the day Afrika Korps surrendered in Tunisia. Approximately 250,000 German and Italian soldiers became prisoners of war. Their combat service had ended, but their education in American manufacturing capacity and industrial philosophy was only beginning. The lessons they would learn as prisoners would prove more profound and lasting than anything they had experienced during the fighting. The contrast between German and American logistical capabilities became impossible to ignore during the journey to captivity. American trucks transported prisoners in quantities that would have required hundreds of horse-drawn wagons in the Wehrmacht, which still relied heavily on animal transport for its supply columns. American Liberty ships, typically constructed in just 5 to 6 weeks at peak production efficiency in 1943, compared to 8 months initially, carried thousands of prisoners across the Atlantic Ocean in converted cargo holds. Every single aspect of the prisoner processing operation demonstrated organizational capacity and material abundance that dwarfed anything Germany had achieved even at the height of its power. At the prisoner processing center in Oran, Algeria, captured mechanics watched American motor pool sergeant service fleets of vehicles with casual efficiency that would have been physically impossible in the Wehrmacht given German parts shortages and maintenance procedures. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The motor pool contained dozens of Jeeps, 2.5-ton trucks, command cars, and specialized vehicles. Young American soldiers, many appearing barely past their teenage years, performed maintenance tasks with remarkable speed and confidence. Tools were abundant, readily available from well-stocked supply rooms. Spare parts arrived without requisition delays or bureaucratic complications. Every vehicle in the motor pool used fundamentally the same basic components, allowing mechanics to service any piece of equipment without specialized knowledge unique to specific manufacturers or models. One American sergeant, who spoke passable German learned from immigrant grandparents in Wisconsin, noticed Richter watching the maintenance operations with intense professional interest. "You a mechanic? Your hands have that look. Grease under the nails never quite comes out, does it?" Richter nodded cautiously. "I was Afrika Korps Vehicle Maintenance Supervisor. Oberfeld Webel." I maintained Kubalwagens, trucks, whatever needed repair. The sergeant grinned, without malice. Well, the war's over for you now, but I bet you've got questions about our equipment. Come on, I'll show you around the motor pool. Not like you can steal military secrets anymore. Besides, there aren't really any secrets to steal. Everything's designed to be simple enough that farm boys can fix it without advanced training. What followed was an educational afternoon that would fundamentally reshape Richter's understanding of American industrial philosophy and manufacturing capability. The sergeant walked him through the entire motor pool operation, explaining American maintenance procedures with unguarded honesty that would have been impossible between combatants, but came easily between a victor and a defeated enemy who posed no further threat. See, the whole idea is that we design everything so any farm boy fresh off the tractor can fix it with basic tools. Most of our mechanics never saw a vehicle engine before they enlisted and went through basic training. Maybe they worked on tractors back home, but plenty hadn't even done that. So we make everything as simple as possible. Color-coded wires so you can't hook things up wrong. Standard bolts throughout so you only need a few wrench sizes. Everything labeled clearly. We've got maintenance manuals written at 6th grade reading levels, with lots of pictures showing every step. The philosophy is that if something breaks in the field, anyone should be able to fix it without calling in a specialist or waiting for a trained technician to arrive. We'd rather have a vehicle that any soldier can repair quickly than a sophisticated machine that requires an expert and sits broken for days, waiting for the right person to show up. Richter examined a disassembled Jeep engine laid out on a workbench for overhaul. Every component was clearly marked with part numbers. The maintenance manual lying open beside the engine contained detailed illustrations and step-by-step instructions that could be followed by someone with minimal mechanical knowledge and basic literacy. The instructions assumed no prior expertise, explaining every operation from first principles. "How many of these vehicles do you produce?" Richter asked. Already suspecting the answer would be difficult to believe, the sergeant shrugged casually. "Hell, I don't know exact numbers, and they probably wouldn't tell me if I asked. But thousands every week across all the factories, I'd guess. They keep coming off the production lines faster than we can ship them overseas to the combat zones. We've got so many Jeeps in depot storage that if one breaks down badly, we usually just grab another one from the motor pool instead of spending time on major repairs. Easier to replace than rebuild when you've got unlimited spares available, thousands every week." The number seemed physically impossible, yet the evidence surrounded him on every side. This motor pool at one small supply base contained more vehicles than entire German divisions had possessed in North Africa. And this scene was being repeated at hundreds of American installations across Algeria, Morocco, Tunisia, and throughout the Allied rear areas worldwide. The sergeant continued the informal tour, showing off capabilities that Wehrmacht logistics could only dream of achieving. Dodge trucks capable of hauling loads that would require 2 German vehicles working together. Half-track personnel carriers produced in such quantities that they seemed commonplace rather than specialized equipment. Tank transporters that could move armor hundreds of kilometers without wearing out the tank's tracks and mechanical components. The thing is, we learned important lessons from the last war about the value of standardization. We build everything with maximum component commonality. A bolt from a Jeep fits a 2-ton truck fits a half-track. Same with electrical parts, hydraulic systems, brake components, everything. Makes logistics incredibly simple. Instead of needing 1,000 different specialized parts, each requiring its own supply chain and inventory management, we need maybe a couple hundred basic components that we produce by the millions. Any part can be used anywhere it fits. This was the fundamental secret that German manufacturing, despite its technical sophistication and engineering brilliance, had never fully grasped or implemented systematically. Component commonality was not merely about production efficiency, though that mattered enormously. It was about creating an entire logistical ecosystem where any part could be used in multiple applications, any mechanic could service any vehicle using familiar procedures, and the entire supply system reinforced itself through simplicity rather than collapsing under the weight of excessive complexity. The journey from North Africa to American prison camps, scattered across the continental United States, continued Richter's education in American industrial capacity, operating at scales that fundamentally contradicted everything German propaganda had claimed about American weakness and decadence. At every stop along the route, prisoners witnessed American logistical operations functioning with mechanical efficiency that seemed more characteristic of German organizational methods than the supposedly chaotic, undisciplined Americans described in Wehrmacht training materials. The port at Norfolk, Virginia processed thousands of tons of supplies daily using mechanical cranes and conveyor systems that loaded and unloaded cargo at speeds that would have required armies of manual laborers in Hamburg or Bremen. Trains carried prisoners across the American heartland in passenger coaches that would have been considered comfortable in peacetime Germany, not the cattle cars that German military logistics would have employed for such transport. And, everywhere, absolutely everywhere, were vehicles beyond counting. Private automobiles filled parking lots outside factories where civilians worked producing war materials. Trucks lined highways in convoys that stretched for kilometers, moving supplies and equipment to ports for shipment overseas. Military vehicles sat in depot storage yards by the thousands awaiting shipment to combat zones, each one representing productive capacity that Germany simply could not match, regardless of how efficiently it organized its more limited resources. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. At Camp Hearn, Texas, captured mechanics with valuable skills volunteered for work assignments in the motor pool. American camp commanders welcomed their expertise because the expanding war effort demanded every available worker, and experienced German mechanics could help maintain the vehicles required to keep the camp functioning. For the next 2 years, through 1944 and into 1945, German prisoners of war worked alongside American soldiers, maintaining the very equipment that represented the industrial might that had defeated them. American mechanics approached vehicle maintenance with straightforward practicality that differed fundamentally from German technical precision. They were not engineers striving for perfection according to theoretical principles. They were problem solvers focused exclusively on keeping equipment operational under field conditions. When something broke, they fixed it quickly, using whatever was available. When proper parts were not immediately available, they improvised temporary solutions. When a vehicle proved unrepairably due to extensive damage, they cannibalized it for components and requested a replacement from depot stocks, which typically arrived within days rather than the weeks or months common in German. Logistics. The captured mechanics observed these American techniques with professional interest, recognizing both similarities and profound differences from their own training. German mechanics had been taught to maintain vehicles to exact factory specifications, requiring specialized tools and proper procedures documented in detailed technical manuals. American mechanics had been trained to keep things running by any means necessary, using whatever tools and parts were available, prioritizing operational capability over theoretical correctness. In peacetime conditions, German methods would produce superior results with longer vehicle lifespans and better performance. In wartime chaos, with supply lines disrupted and specialized parts unavailable, American methods proved vastly more effective at maintaining operational readiness under adverse conditions. The motor pool at Camp Hearn processed hundreds of vehicles monthly in continuous rotation. Jeeps came in for routine maintenance and received service in hours rather than days and returned immediately to duty. The efficiency derived from two fundamental factors that German logistics had never achieved systematically. First, parts abundance meant that mechanics never waited for components. The parts room maintained inventory levels that would have seemed criminally wasteful in resource-constrained Germany. Second, component interchangeability meant that any part fit any vehicle of that type without modification or adjustment. When a part needed replacement, the supply sergeant simply walked to the parts room and selected one from dozens of identical units in stock. When a tool was required, The tool room provided it immediately without requisition forms or authorization procedures. When a vehicle sustained damage beyond economical repair, another one replaced it from depot stocks without affecting operational capability. Richter befriended an American soldier named Thomas Bradford, who had worked for Ford Motor Company before being drafted in 1943. Bradford proved knowledgeable about the American automotive industry and willing to explain manufacturing processes to his former enemy with surprising openness. Before the war, I worked on the assembly line at Willow Run. That's Ford's bomber plant outside Detroit, biggest factory building in the world under one roof. We're building B-24 Liberators there. Started production in early '42, and by the time I got drafted last year, we were completing one finished bomber every hour during peak shifts. Every single hour, a complete four-engine heavy bomber weighing 30,000 pounds rolled off that assembly line, ready for final inspection and delivery to combat units. The arithmetic was staggering, almost incomprehensibly. 24 bombers per day, over 700 per month, thousands per year from a single factory, just one among hundreds producing war materials across the United States. How is such production, even possibly? Richter asked, genuinely trying to understand the industrial processes that could achieve such output. Germany's most efficient factories could not approach these numbers. Mass production principles perfected over decades, Bradford explained patiently. Mr. Ford figured out how to break down complex manufacturing into simply, repeatably steps that anyone can learn quickly. You don't need skilled craftsmen spending years learning their trade if every worker performs one simple task repeatedly until they can do it perfectly without thinking. A kid fresh off the farm, with no industrial experience, can be trained in a week to install one specific type of bolt in one specific location. Do that with 1,000 workers, each mastering one simple operation, and you achieve massive output without requiring highly skilled labor. This was the fundamental difference that determined the war's outcome more certainly than any battle or campaign. German production relied on skilled craftsmen building quality products in moderate quantities using traditional methods. American production relied on semi-skilled workers building adequate products in massive quantities using systematically organized assembly line techniques. The German approach produced objectively superior individual examples. The American approach produced overwhelming numerical superiority that buried quality advantages under sheer quantity. Bradford continued his explanation, warming to the subject. Same basic principle with Jeeps and trucks. Willys Overland manufactures Jeeps in Toledo, Ohio. Ford manufactures them in their plants using identical specifications. Apart from a Willys Jeep, fits a Ford Jeep perfectly because they are completely interchangeable despite coming from different manufacturers. That means if one plant gets bombed or has production problems, the other keeps manufacturing without interruption. Supply chains remain stable. Maintenance stays simply because every mechanic learns procedures for one standardized vehicle, not dozens of different variants with unique requirements. Richter thought about the Wehrmacht's vehicle inventory with growing dismay. Dozens of different truck types from various manufacturers, each with unique parts and maintenance requirements specific to that model. Kübelwagens from Volkswagen. Command cars from multiple sources. Captured vehicles from across Europe, each requiring its own spare parts and specialized knowledge. German logistics were an absolute nightmare of incompatible systems that required extensive coordination and specialized expertise at every level. American logistics were deliberately streamlined through rigid uniformity, fewer vehicle types, standardized components, interchangeable parts. Simpler procedures that any trained mechanic, the system was self-reinforcing, becoming more efficient as it grew larger rather than collapsing under its own complexity the way German logistics increasingly did as the war progressed. The real genius, Bradford said, is that we designed for manufacturability from the very start. When the Army put out requirements for the Jeep back in 1940, they gave companies just 75 days to produce working prototypes. American Bantam did it in 49 days. Then, Willys and Ford refined the design specifically for mass production. Everything had to be simple to manufacture with standard machine tools, simple to maintain with basic hand tools, and simple to repair using common parts available anywhere. The captured mechanics had examined enough Jeeps by this point to recognize this truth viscerally. The vehicle was not elegant in the way German engineers defined elegance. German engineers would have designed something more sophisticated, more refined, more theoretically perfect. But sophistication impeded mass production, and mass production was actively winning the war through material, abundance that no amount of German tactical brilliance or individual courage could overcome. By summer 1944, prisoners had begun hearing rumours of Operation Overlord, the massive Allied invasion of Normandy. When news arrived of the landing's success on June 6th, many German prisoners felt no surprise whatsoever. The Allies possessed the manufacturing capacity to build an invasion fleet that would have taken Germany years to assemble, even if it controlled all the resources of occupied Europe. The mathematics were brutally simple. America could build faster than Germany could destroy. News filtered into the camps through American newspapers and radio broadcasts that guards shared with cooperative prisoners. They read accounts of the Normandy beaches where Allied forces had landed with thousands of vehicles in the first wave alone. Jeeps, trucks, tanks, amphibious vehicles, all carried across the English Channel in purpose-built landing craft that were themselves manufactured by the thousands in American and British shipyards. The scale of Operation Overlord defied reasonable comprehension. 6,000 ships, 11,000 aircraft, 150,000 men in the first wave alone. Within weeks, millions of Allied soldiers would be fighting in France, all supplied by a production base that created equipment faster than the Wehrmacht could destroy it through combat action. German prisoners reflected on their pre-war confidence in ultimate victory. That confidence had been based fundamentally on assumptions about German technological superiority and military excellence. Those assumptions, while not entirely wrong, had proven catastrophically incomplete. Germany did have superior engineering in many specific areas. German tanks were more heavily armoured and better armoured than most American equivalents. German aircraft were often more sophisticated. German small arms were excellent by any objective measure, but none of that mattered strategically when America could produce 5 Sherman tanks for every 1 Panther Germany built, 10 trucks for every German truck, 100 jeeps for every Kübelwagen. Superior quality could not compensate for overwhelming quantity when the numerical disparity reached such extreme levels. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today.